All right, let's talk about SAT geometry. But forget all those endless proofs and theorems you had to memorize in high school. Today, we're not just learning rules, we're building a mental toolkit. The goal is to see right through the test's tricks and solve these problems with speed, and more importantly, with confidence. Let's jump in.
This right here, this is the one idea that's going to change everything for you. Think about it. When you build IKEA furniture, you get a box, a bag of screws, and a little instruction booklet. The test isn't asking you to be a master carpenter, it's just asking if you can follow the instructions perfectly. If you find yourself trying to invent some crazy new solution, you're probably doing it wrong. The answer is always in the instruction manual.
So let's open that manual to page 1. We're starting with the absolute foundation, lines and angles. These aren't just suggestions, they are the unbreakable laws of geometry on the SAT. If you get these down, everything else just clicks into place.
This number, that's it. Just 180, I want you to burn this number into your brain. Seriously, it is the master key that unlocks more geometry problems on the SAT than any other concept. You're going to see it pop up everywhere. And here's the first and simplest place you'll see it. Any straight line is 180 degrees, full stop, no exceptions. If they give you one of the angles on that line, you automatically know the other one. It's a guarantee. Now, here's the thing. The SAT knows this is easy. So what do? They hide it. They'll bury this simple straight line inside some crazy, complicated-looking diagram. They're betting you'll get intimidated and overthink it. Don't fall for that. Find the straight line, find your 180 degrees, and ignore all the noise. Okay, here's another freebie. A total gimme from the test makers. When two lines cross, the angles directly across from each other are identical. They're like looking in a mirror. If one is 50 degrees, so is the other. You don't have to calculate anything, you just have to recognize it. All right, you are absolutely 100% going to see this on the test. It's the classic parallel lines cut by another line. You just have to know these three relationships cold. Corresponding angles, they're in the same spot at each intersection, so they're equal. Alternate interior angles, opposite sides inside the parallel lines, also equal. And the only odd one out is same side interior. Those two add up to our magic number, 180. These are guaranteed points, so don't leave them on the table. And here's their favorite trick with this stuff. They'll take this simple diagram and flip it upside down, turn it sideways, anything to confuse you. But guess what? These rules couldn't care less if the picture is rotated. The rules are the rules. Your job is to find the parallel lines and apply the rule, no matter how they try to disguise it.
Okay, so we've got our foundation poured. Now it's time to put up the frame of the house. And in SAT geometry, that frame is always triangles. They're the backbone of almost every complex problem. If you master triangles, you master the section. And trust me, we're going to make it simple.
Hey, look who's back, our old friend, 180. And this is not a coincidence. The fact that 180 is the key number for both straight lines and triangles is one of the coolest and most important connections in geometry. And here's the big reveal. It doesn't matter what the triangle looks like, tall and skinny, short and fat, whatever, the three angles on the inside will always add up to 180 degrees. This is a non-negotiable law of the universe. So if the SAT gives you two of the angles, that third one isn't a mystery. It's just a simple subtraction problem. Okay, lean in for this one, because this is a pro move, a serious shortcut. See that angle on the outside? It's always equal to the sum of the two angles on the inside that are farthest away from it. Now you could find the third interior angle and then subtract from 180, but that's the slow way. The SAT throws this in there because they're betting you forgot about it. Don't let them win that bet.
So not all triangles are the same. They've got their own little personalities. Equilateral is the perfect one. All sides are equal, so all angles are equal. 60, 60, and 60. Isosceles is the symmetrical one. It has two equal sides, which means the two angles opposite those sides are also equal. And then there's the rock star, the right triangle, with its perfect 90-degree corner. This one opens up a whole new set of tools.
So speaking of that right triangle, let's get into the advanced stuff. These are the moves that separate the good scores from the great scores. This is where you really start to unlock the hidden clues in each problem. Ah, yes. Good old Pythagoras. A squared plus b squared equals c squared. But here's the key. You don't just memorize it, you learn to spot it. Anytime you see a right triangle, anytime you see that little box in the corner, your brain should immediately start humming this tune. It's famous for a reason. It just works.
But of course, the SAT isn't just going to hand you a perfect right triangle and say, go for it. They hide them. You have to be a bit of a detective. If you draw a diagonal line through a square or a rectangle,
Bam! You've just made 2 right triangles. And they love hiding them in coordinate geometry problems with graphs. Your job is to find them.
Okay, this slide right here, this is your secret weapon. This is free time on the test. These 2 special right triangles show up all the time. And if you know these side ratios by heart, you can skip the Pythagorean theorem entirely. It's a speed trap for people who don't know the shortcut. This isn't just about getting the right answer, it's about getting it fast.
Let's get this straight, because people mix these up all the time. Congruent is easy. They're identical twins. Same shape, same size, same everything. All the sides are equal. Similar is more like family. You can tell they're related, they have the same angles and the same general shape, but one's the big brother and one's the little sister. Their sides aren't equal, but they are proportional. And the SAT loves to test you on those proportions.
All right, we've gone over all the rules, all the tools in our IKEA box. But the last piece of the puzzle isn't a formula. It's not math at all. It's psychology. It's about understanding the game you're playing.
So let's pull back the curtain and look at how the test is actually designed to trick you. Because once you see the traps for what they are, they completely lose their power over you.
Here they are, their greatest hits. And the number 1 trap, the one that gets almost everybody? Trusting your eyes. Unless a problem specifically states figure drawn to scale, you have to assume it's lying to you. An angle might look like it's 90 degrees, but if there's no little box, you can't assume anything. You must trust the rules you know, not the picture they show you.
And that brings us to the most important point of this entire thing. The problems are rarely as complex as they look. The trap is designed to make you doubt a simple rule you already know. The test isn't really about your math skills, it's a test of your confidence in the fundamentals.
So what's the takeaway here? What's the goal? It's not about memorizing 100 different formulas. It's about developing instant recognition. It's about looking at a messy diagram and immediately seeing the pattern, seeing the parallel lines, spotting the hidden right triangle, knowing that the angles have to add up to 180. That is how you win the game.
So this is what I want you to repeat to yourself when you see a geometry problem. No drama, no overthinking, no panic. See the pattern, apply the rule, find the answer, and move on. Quiet, efficient, deadly.